Hello, welcome to my Module 2 presentation. Today I'll be reviewing both moderation and mediation and addressing these two questions here. For this case, I'm interested in understanding the social media world and how influencers can become successful in social media by posting, but also seeing if there is some moderation or mediation effects that can help explain this complex relationship of how to become successful as an influencer. So first, we're going to start with moderation. And for this, we're going to have three variables. Our two continuous variables will be our outcome, which is fame, which is measured by the amount of followers an influencer has on social media. Our X is our other continuous variable, our predictor. And this is the amount of posts that a social media influencer makes per week, posts or stories. And then our binary predictor, in this case, our moderator, is biological sex. So this will be defined as 0, the group 0 being males and the group 1 being females. So now what is moderation? So a moderator is a variable that alters the strength of the relationship between our X and our Y. So the effect of X on Y depends on the level of the moderator. It's of some sorts a logical and it just adds complexity to our model because it adds an interaction. And an interaction is the unique combined effect of the two predictors. So in this case, amount of work or amount of posts and sex combined together to go above and beyond their separate main effects on our outcome. So you can see this here by our equation. We have our two main effects, which are amount of post and sex, and then we have our interaction effect, which is considered a higher order effect, and this is our interaction of post and sex. And it's interesting to note that the interaction term here being B3 is always residualized because it's what's left over after the main effects. So main effects in type 2 sums of squares that we're using get their portion first, and then whatever is left over to be explained, that is when the interaction comes in to try to explain their unique variance with our outcome variable. So we run a diagnostic plot on this model and it looks pretty good, nothing too concerning. I will note that we did center our two predictors in this model, centering the mean of 0 of our predictors. And we did this for various reasons. We did this because we are including an interaction, and having both main effects and an interaction affects our model. And by centering, it allows us to make our regression coefficients of our main effects more meaningful. It also helps address issues of scaling concerns because our X and our moderator are combined together to make our interaction, so they will correlate. And without centering, this is considered non-essential multiclinearity because we don't need that. But we center this and then we're left with what is called essential multiclinearity, which is then merely just the correlation between our X and interaction that's due to the skewedness in X. So this is what we're left over with after centering. And you can see that here in our VIF, which is the correlation between our predictors. The top is our uncentered model, and then below is our centered model. So you can see once we centered, the VIFs decreased for the most part. And this is showing that we're left with what is just essential multiclinearity that we can't get rid of. So let's look at our output. First off, we can see that everything is significant. Both our main effects, being post and sex, are significant, and our interaction term is also significant. In this case, our B1, which is post, is the average effect of participants' posts per week on their social media success at the average reported sex by participants. And our B3 being our interaction coefficient, and this represents the effect of the interaction if and only if the two predictors in their interaction are in the regression equation. So a lot of times when people see a significant interaction, they want to throw out the main effects because that's what they're interested in. That's the cool thing to look at. But we don't want to do this. If we throw out our main effects, then all of that variance explained by our main effects is now given to our interaction term, which is just going to confuse the unique variance that the interaction term can actually explain, because we want to partial out our X and our moderator from the interaction term. So we just see the unique variance of the interaction term. So we can also look at this through hierarchical testing, and this is just a way to sequence our models, and we can still see that at each model there is significance. So this is telling us that the moderation analysis tells us that the effect of the amount of posts made by an influencer on their social media success is significantly different for males and females because we have significant interaction. We can also look at this visually through an interaction plot. And so through here we have two lines, one being red for males and blue for females. And this is calculated using our simple slopes and simple intercepts, which is just a way for us to take our interaction and turn those terms back into main effects model. So we have two regression lines. And you can see that there is an interaction because our lines cross at this point and we have a difference in our slopes. telling me that the regression of y on x is changing as a function of our moderator. So this shows that gender does influence the relationship between the amount of posts per week and social media success. And in fact, for women, there seems to be a steeper increase with the amount of posts they have and their social media success than men. So is there an interaction? Yes, there is an interaction. The effect of amount of posting per week on an influencer's social media success does differ depending on their sex. So adding the interaction term helped us explain some more complexity of this relationship between just X and Y, or even our moderator and our outcome. However, we do want to be hesitant about moderation analysis and completely taking them because we can have issues with power, specifically because of measurement error, as our interaction term is made up between our two predictors. If there's measurement error in our predictors, that's going to be passed on to our interaction. So we just need to be cautious with that, so make sure that our predictors are measured well. So now we can move on to mediation. What is the difference between a mediator and a moderator? Well, in a mediation, there is a causal pathway that is temporal between X, M, and Y. So there's a pathway that is followed. While in a moderator, the moderator is merely just influencing the established pathway from X to Y, and there's no temporal relationship and there's no shared causal structure. However, both are predictors in our model and are used as third variables to help explain some of the complexity that we see with our outcome variable. So here again, we have our histograms. We do have similar Y values and our X's, but they're defined a little differently. So in this case, and they're all continuous variables, our dependent variable is social media success. And this is measured as the number of brand deals an influencer has. Our X variable is still the amount of posts an influencer makes per week. And our continuous mediator is relatability. So this is measured on a Likert scale of how relatable social media influencers view them as, and this was just calculated through outside data set. So then we have this causal pathway that I was mentioning. So a mediator is a variable that explains the underlying mechanism of the relationship between X and Y. So what is actually happening here? Well, to understand that, we first have our C pathway. So this is our bivariant relationship between our X and our Y. And this is what we consider a direct effect. Then as we go up, we see we have both indirect and direct effects. So indirect effect is A and B because it's not going straight from X to our Y, and the C prime would be an indirect or a direct effect. So our A pathway is explaining the relationship between our X and our M, and for there to be a mediation for us to even consider it, this needs to be significant. Then we have our B pathway, which is our mediator to our outcome variable. And we would also like this to be significant as well, because then that would mean we have a significant indirect effect, which would lead us to fail to rule out mediation because there's something else going on. Then again, we have our second direct effect. So C prime is different than C because as C is in a bivariant relationship, C prime is in a multivariate relationship because you have two predictors. You have your frequency of posts and your relatability. And C prime is saying what is the relationship of X to Y while controlling for M. So in theory, when we control for M, we would want C prime to be 0 because if there's as Kinney notes in their 2018 piece, if there is a complete mediation, which would mean C is 0, this means that X no longer affects Y after your mediator has been controlled for. So there's no direct effect to be significant because all of the effect is going to your mediator. However, that's not that common in the real world and what we deal with. So we mainly deal with partial mediation, which partial mediation means the path from C to Y is still significant, but it's significant to a lesser extent, seen as your B coefficient decreasing from your C pathway to your C prime pathway, showing that there is some shared variance because we're now in a multivariate model between our X and our M that is being explained in this model. So I conducted diagnostic plots for each of these different models because in mediation, it's just a combination of different regressions, bivariate and multivariate, and hoping to explain the causal pathway. And we can see here, we're not really concerned about anything. Nothing pops out. And here I have a correlation table, and I decided to include this to show that our two predictors are going to be correlated with each other to an extent because as Kinney in their 2018 article also mentioned, if M is a successful mediator, it is correlated with X because of our path A that we mentioned. So we are going to expect collinearity and we're going to expect multicollinearity, but there's nothing we can do about that and we're not really worried about it. So now we can follow on to our mediation analysis step. So is there a mediation? Can we rule it out? And so we follow our Barron and Kenny 1986 steps that they explained in their article. And it basically just walks you through each of the pathways that I mentioned earlier. Our C pathway not included in this graphic, but it is here at the bottom, the bivariate relationship. So you're checking to see the significance of each of these steps. So we'll go ahead and do that. So our first step is checking our C pathway to see if that's significant. Some think this is necessary, others don't. We decided to do it just to see. And we do reject the null hypothesis. So the probability that there's no relationship between the amount of post influencer has and their social media success is low. And then we check our A pathway, also significant, which is great and what we want to see. So the probability that there's no relationship here is also very low between our predictor and our mediator. And then we have our multivariate relationship, which gives us here our B pathway and here our C prime pathway. So we can see that we reject the null hypothesis for our B pathway of there being no relationship. And we also see that we have a significant relationship in our C prime pathway. So that's telling me that we don't really have full mediation because we would expect this to not be significant in the case if we did. So it's telling me we could probably see some partial mediation because our C prime is still significant. And you'll note that the B value for our coefficient actually decreased as we would expect as well due to the shared variance that we were expecting with our mediator. So now we need to analyze actually what we are seeing and to test our indirect effects. So before we usually would test this with the Sobel test using a z-score and expecting our p-value for that score to be below 0.05. So we check this out, it's good, but Sobel has a lot of shortcomings such as low power and having assumptions of normality and alpha slippage. So we don't use this typically anymore. What we have moved more towards is bootstrapping. And bootstrapping, as Kenny describes in their 2018 piece, is a more popular method. And it's a sort of parametric method based on resampling with replacements that's done many times. So in this case, it's done 1,000 times. So we can get a larger idea of what our coefficients are going to look like and just are able to generalize our model more, which addresses issues of, as Preacher and Hayes point out in their 2008 piece, address issues of power and normality that we saw in our Sobel test. So this helps with standard errors and it just overall increases the power of our predictions. So we can look here and we see our first ACME. This is our average causal mediation effect, so our indirect effect. Then we have our direct effect, total and proportion mediated. All of these are significant, telling me we have a significant indirect effect and a significant direct effect. And our portion mediated also significant. So all of these being significant is telling me that we cannot rule out mediation, which is what we're actually testing for, and that perhaps it's partial mediation because we still see the significant direct effect. So we also need to conduct a sensitivity analysis, which we do to know to what point we can be confident in our indirect effect, so how sensitive our mediator is. And you can see here with our rho being at 0.4, that is when 0 starts to be introduced into our confidence intervals, telling me that we need to perhaps worry about certain confounds in our model because the sensitivity analysis addresses the assumption that there's no relationship between the residuals of the mediator and the outcome. But we see here at about 0.4 correlation, we start to worry about that. You can also see here at the bottom of our 9%. So this is telling us that we don't have a lot of security of our accounting for variance for over 9% of the variance in our model. So at 9%, we're good. Over that, not so great. So what does this mean? This is telling me that in order for us to really claim there is a large mediation or a partial mediation, we do need to conduct more research and make sure we know what is going on. But perhaps there is a temporal relationship. To be a social media star, you have to post a lot so you get recognized, and then you have to be relatable in order to get brand deals and be successful. But also just the amount you post per week still does predict your social media success with reliability or relatability held constant. So if you do something enough, you are still going to get brand deals, but there is both that indirect relationship and direct relationship that we saw here as we have a partial mediation most likely. But we do need to be cautious, as Barron and Kenny pointed out in their 1986 piece and Preacher and Hayes in 2008, since our C prime is not 0, we could have additional mediators that we need to look into or more complex relationships. So overall, sex does appear to influence the relationship between an influencer's posting frequency and their social media success, and we cannot rule out relatability as a mediator for the relationship of posting frequency and social media success of an influencer in ways of generating brand deals. But overall, we should explore more relationships in this model to really understand this complex relationship of social media success for an influencer, because there could be more to see. Thank you.